Hello and welcome to the CAD tutorial channel. Today we're going to be taking a look at Solidworks and the FEA meshing options that we have available. Specifically, we're going to look at 3 different meshing techniques with that. So this should be a pretty good short video for us to kind of dissect a few of the options. I'm going to create a simple part here of a stress concentrator. So we'll create a rectangular box. This is similar to some of the other videos that we've posted in regards to FEA, and we'll make it 4 units by 2 units. And we'll put a hole in the center. And we'll make that 1 inch. Okay, so what we should see when we do an FEA analysis of this is we have a concentrated stress located right here on the top and the bottom of the arc. We'll just extrude this out 1/4 of an inch. Okay, and before we go ahead and move over to FEA, let's go ahead and make sure we have a material assigned to this, so that we take care of that here in the part file rather than in the FEA function. So for today, let's go ahead and use aluminum alloy. Let's use 6061. It really doesn't matter. Our main purpose here is to take a look at the meshing techniques. Okay, so our modeling is done. We'll head on over to Simulate and a new study. And we'll just do a static study here with the defaults to set up. All right, so I have my part file made. We have a few little things that we need to set up. Nothing too severe. We're going to fix geometry on one side of it. And then we're going to use external load force on the opposite side, and we'll make that a pulling force of 500 pounds. I need to reverse it. Okay, that should be good. All right, so we have everything taken care of with this. Now it's time to start to take a look at the meshing options. So our default meshing option is, if I go ahead and just create the mesh, brings up a dialog box here, and this is a global mesh control for us. And the primary thing that we have here with the basic features is we can use the slider to move from a coarse mesh to a fine mesh. We'll just leave it at the default, and we'll go ahead and click OK, and we should have our mesh created. In order to see what's going on with the mesh, like an inventor, we'll have our nodes and elements located up here. The only way we really can find that is by right-clicking on the mesh and going into details on that, and it should show us our total nodes at about 11,000 and our total elements of just a hair under 7,000. So specifically, our nodes are the edges of our triangles, and the elements are the triangles themselves. And we take a look, it's pretty evenly distributed on here. And this was a medium mesh setting. Our meshes handled the curve here fairly well. So this is a fairly good first step in our meshing feature. From here, we can just go ahead and run the study and see what we get as a result. So I'm going to change my value here to inches. So I do that under right-clicking on the chart and chart options. And in my chart options, I'm going to go ahead and change my value to floating. And then definition, I'm going to change that to, let's go ahead and do KSI. All right. So it's showing that I have a maximum stress occurring right where we were anticipating it to, at about 4,277. At this point, if I'm going to use the global strategy, I would just record my values for my mesh, which we were back on that detail sheet at about 11,000 and 7,000. And then I would record my value here and indicate kind of where it was at. With this approach, my next step then would be to edit the mesh. And take and refine it a little further down the scale. I don't need to go too far, but just a little bit. So this should increase the mesh density. And we can check that by going into details. And we went from 11,000 and 7,000 to 24,000 and 15,000. So pretty big jump there. And then we would rerun our results. And I went from 4,277 to 4,400. So we had about a jump of 130-ish. The load is still concentrated where we anticipated. And I would probably run one more time and refine the mesh a little further to try and get these values as we run the multiple studies to converge a little bit more tightly. But we're getting close. Probably one more run should get us there. So this is kind of the first approach that we can take with just using global mesh options for that. Okay, so that's kind of the first pick our way through it. Our second method, so we'll start a new study, is we're going to go ahead and run the same thing. We'll set it up the same way. So we'll fix the one side. And we'll put the same load on. Same direction. All right, and we'll put our mesh in. And it should be about the same mesh as we saw in the first study. But this time, we're going to use a local mesh control. And we're going to place that local mesh kind of where we know where the stresses should be occurring at. So I'm going to right-click on my mesh and do Apply Mesh Control. And on my mesh control, I'm going to pick the edges of the arc. And we'll go ahead and just accept the defaults. Okay. We'll go ahead and create the mesh. Notice you have the little icon that says it needs to be remade. Okay. And now we can see that our mesh has increased specifically where we are anticipating to see the stresses occurring. Notice out here in the field, we're pretty simplified. So we'll go ahead and run this study and see what our results are. All right, let's go ahead and change our values so that we can compare them to our first study. So I'm going to change to floating and my units to KSI. Okay, so this go around, we're at 4376. So that's pretty close on our first run to our second run in our global changes. And what I would probably do with this is refine the mesh one more time at least and see if I can still keep my numbers pretty tight, some type of convergence. But I'm relying on myself and my experiences to help me define my meshes properly with either of these first two techniques. Our third technique, so let's start up a third study, is something that's available in Solidworks for us. And so let's go ahead and get this set up again. Fix that side. We'll keep everything exactly the same. All right, when we go ahead and make the mesh this time, I'm going to move past the beginning screen here on the mesh density. And I'm going to move down here to the mesh parameters. So far we've only used the standard mesh. The curvature mesh works much better when we have radiuses and arcs in our model. It's going to create a curvature that's slightly different for us. And so that is going to give us a little better characteristics where we may not need a local mesh control around a feature like this. So by just changing this method, it's going to take slightly longer to do the calculation on the mesh, but it's going to give us a much better mesh right off the bat for us. So we'll leave it right here in the middle, and we'll see what it generates for us. So you can kind of see the pattern has changed. It's taking into account the large arc here and tried to form that around there. If we go to mesh details, remember our first and our global setting was about 11,000 and 7,000. Right now we're at 17,000 and 10,000. So the mesh is a little more refined right in the middle setting, and it's more refined where we're anticipating to see our stresses at. Okay, so let's go ahead and run the study and take a look at our results. My recommendation is we try and use the curvature mesh as often as possible. It's a good starting point. So even though we have tried the other methods, this is probably where I would begin most of my modeling at with the FEA and Solidworks. So here we're coming in at 4408 as our first value. I would probably refine the mesh one more time using this method and bring down, slide that bar over a little bit and see if I can keep the values tight. But needless to say, what we're seeing here in all three different examples so far is that our value is really somewhere between like 4,375 to probably 4,420. So we're indicating to ourselves that we're getting pretty tight and know kind of where our anticipation of our results should be and the value it should be. All right, we're going to take a look at one more option, and this is actually probably the best option for us. So we're going to do a new study. And this one does take the most time to set up and work, but it takes our multiple runs out of the equation and lets the software handle those multiple runs for us. So here we'll do the same thing. We'll set up a fixed side. And we'll put the same load on. Okay, so we're back in good shape here. Rather than going ahead and create the mesh to begin with, I'm going to come up here on my static analysis number 4 that we're on, and I'm going to go into properties on that. And in my properties, I could have done this right off the bat on creating the study, but we can do it right now. I'm going to change to the second tab, which is adaptive. By default, we don't have an adaptive method in set. I'm going to go ahead and change this to the H adaptive method. I'm going to then go ahead and set my target accuracy to either 98 or 99%. We'll just use the 98 for default. My accuracy bias, I'm going to leave right in the middle. And my maximum number of loops, I'm going to set this to 5. 5 is really the most that we want to set that to. This means how many times it's going to try and reach some convergence in our model, in our FEA analysis for us. We don't want this to run forever if it can't do it, so that it creates a loop that is endless. So 5 is a good number. If we don't reach our convergence in 5, we can just rerun it and it'll pick up from where it was and run another 5 possible loops to try and find that convergence. So this is about the best number that we should have in here. The other option we have in here is mesh coursing. This is a great button, especially when we have long or large sections of flat that really have nothing that is going to change in the model. So by using that, it's going to interpretate the mesh and make this area potentially much larger in size for the meshing elements, and then where we're going to find the stresses occurring much smaller. So it could save us some CPU power, especially on very sophisticated modeling. So it's a good choice, especially in this type of situation we have here. All right, with that set, we'll go ahead and click OK. And we'll go ahead and create the mesh. We'll use a curvature-based mesh for this in the middle setting to begin with. And so here's the mesh that it began with. And then we're going to go ahead and run the study. Okay, so it ran through a couple of pieces there. And what it does is it pops up a message and says, the analyzation has satisfied the current H adaptive accuracy of 98.4%. We could increase the target accuracy and rerun the study, but it's run a couple of studies to get us here. And we'll go ahead and click OK, but it feels it's satisfied our needs. So let's go ahead and see what our results are, comparably speaking. And it's coming in at 4408 right off the bat here. If I go to my mesh details, we can see that we're about 17 and 17,000 and 10,000 on those respectively. And you can now take a look at the mesh that is created to satisfy this. So we're getting a little tighter where we are anticipating it to happen, and so on. All right, I want to take a look at one more thing here. And under results, I'm going to define the adaptive convergent graph. And I have a couple of options here. Rather than using target accuracy, I'm going to switch to maximum von Mises stress for my accuracy on that. Okay, and let's go ahead and rerun the study. Let's go ahead and add in didn't take it. Okay, let's try again. There we are. So here we're seeing our loops, and we're seeing the value isn't really increasing, and it's giving us our convergence factor that we're well within that margin that we've set. If I went to 99%, then we would probably see a little more variation in this feature. We can go ahead and give that a try by going back into our properties, adaptive, and we can change that to 99. And we'll see if we get any difference in our results. Okay, we did get a little bit of difference. We're at a 43.96, but it's pretty tight in that. Notice I didn't get my convergence message in that run. So if I rerun the study again, it should pick up where we left off. And let's take a look at our convergence map. Okay, so here's our map. I left on target accuracy and von Mies, and you can see our von Mies stretched across our loops, and we dropped about 0.4% on our stress across the multiple runs on this. So this is a way for us to do convergence in Solidworks that I don't think a lot of people know where to find this at. Inventor, Autodesk Inventor does this a little bit differently. It's more up and center and visible for you. But here's the way that we would do this in Solidworks. I hope you give this a try, and this helped you with your meshing techniques in Solidworks. We took a look at a variety of different methods for that, and I wish you luck and hope this helped you. As always, please subscribe to the channel to see more CAD videos like this and a variety of CAD software. And if you have an idea for our next video, please leave it in the comments below. Thank you and enjoy.